Okay, we're going to continue the notes with confidence intervals for distributions, Z distributions for the means, where the standard deviation of the population is known. This time we're going to be working with data. So we're going to have to enter data, and this will be the first time that we've done this. So this is scenario 2. In a 2-lane road with a posted speed limit of 55 miles per hour is located just outside a subdivision. The residents of the neighborhood are concerned that the speed of cars on the road is excessive and want the police to step up patrols. To gather evidence, the homeowners desire to estimate the mean population speed of cars on the road. The residents decide to take a random sample and measure the speed of 12 cars on the highway during 9 peak times. These are the speeds. The residents wish to construct a 90% confidence interval about the population mean. Assume that the standard deviation of the population in miles per hour is known and the distribution of speeds is normal. So we want to construct a 90% confidence level. We're going to take our look at our recipe, and our recipe says, well, the very first thing we need to do is define the parameter mu in context. And we know we're going to start off by writing let mu equal the true population mean. So number one, we're going to start off by let mu equal the true population mean. And what are we interested in the mean? Well, we're interested in the mean of the car speed, so mean car speed. All right, number 2 is the conditions, and we're not going to concern ourselves with the conditions in this course, so we can just write assumed. Now we do know this is a random sample that's representative of the population, and we know it's normal, etc. They told us that. The next thing said, step 3 says write the formula for the test, so that's easy enough to do. So number 3 is going to be x bar plus or minus z star, the standard deviation of the population, divided by the square root of n. Our next step is different than what we've done before because it says enter the data. And they did give us data, and so we're going to need to enter this data, and it basically says enter the data using stat edit, a part of the calculator, and enter it into column L1. All right, well, I've kind of worked ahead and kind of done that, so you may need to pause the video to do this. So I'm going to press stat, which is in the middle of the calculator, and edit's highlighted. I'm going to just go ahead and press enter. And then I typed in 57.4, 56.1, 70.3, etc., until I had all 12 data points entered. Okay. Once we have that, it says identify and label all your parts. Okay. So to do that, I'm going to need to go stat, arrow over to calc, one variable statistics. And my list happens to be an L1. So I'm going to press second 1, and I end up getting an X bar of 59.616, the standard deviation. They told me what that was. So when we look at this, it gave us a list in the order that the calculator works. So our list is standard deviation equals, so what was our standard deviation of the population? Well, they told us that, and they told us that we entered, so we did the data. So now we're on to number 5, and our standard deviation in this case is 8, and they gave that to us up here. We're not going to use the one from the calculator. We're going to use the one that they gave us. And then the next thing it asked for is X bar, and our X bar came from the calculator, and 59.616. And the very last thing that we know we need to write down is our sample size, which is n. And in this case, n equals 14. Okay, so we've entered our data and we've gotten some information. And now we're on to calculate Z star. All right, so calculating Z star is probably the most difficult part. So we need to make sure when we do this, we're going to go to second vars and we're going to use 1 minus the confidence level. Well, we need to turn that into a decimal. Well, our confidence level in this time, they said make it 90%. So here we go. second vars inverse norm area is going to be parenthesis 1 minus 0.90, close parenthesis, divided by 2. And since it's a z, we're always going to have a mean of 0 and a standard deviation of 1. And we're going to calculate this. And we get a z star. So this is number 6. And our z star equals, in a set, we made a little note to ourselves to always make it positive. Technically, you can work with the negatives, but your life will be much easier if you make it positive. Number 7 on the recipe says plug into the interval. Okay, so we're going to go ahead and plug into the interval and calculate the confidence. So we're going to plug in and we're going to go, all right, X bar up here was 59.616. So 59.616 plus or minus, what did we get for Z star? We got 1.6445. Our standard deviation was 8. So 8 over the square root of 14. And I put parentheses around there to kind of separate my work. Now we're going to go ahead and calculate the interval. So we're going to go stat, which again is in the middle of the calculator. So stat, arrow over to test. And what we want is our Z interval, which is number 7. All right. So since we use data, let's arrow over till we highlight the word data. Our standard deviation is not 6.5, it was 8. We put our data list, our list and data in L1. So we're going to press the second button followed by the number 1, and that should give you an L1. Our frequency is 1. And we need a C level or a confidence level of 90%, so 0.90. And we end up getting an interval, and that's the next step, is to write our interval. And our interval this time is 55.818 to 63.415. All right, so we've now written our interval, and the next step we need to do is write our conclusion. So before I write our conclusion, I want to talk about that. So let's look at our recipe for just a second. And it says we are blank percent. Well, that's our confidence level. So this will be, we are, in our case, 90% confident that the true population mean, and this is where we're going to put in number 1, whatever we wrote for our parameter definition lies within the interval, whatever we just calculated, lies within the interval of number 8, where we calculate that. So let's try that out. And I'm going to put this over here because I'm running out of room. So I'm going to skip up over here to the top and write number 9. So number 9, we are 90%, because that's our confidence level, 90% confident that, and we're going to just use our definition right here, that the true population mean car speed lies within the interval. And what was our interval? Well, we calculated it here, and it was 55.818 to 63.415. And that takes care of number 9. Number 10 is explaining the meaning of the confidence level. Now, they didn't specifically ask us to, but we're going to do it for the notes purposes. But generally speaking, it'll say explain the confidence level, and you go, okay, I have to do number 10. All right, so let's talk about what it says. It says in repeated sampling, we expect that this method will capture. So we're going to write this regardless. Then we're going to say the definition we wrote in number 1 again is whatever our confidence level percent of the time. So if it's been typed, we copy that directly, and then we're going to fill in whatever our definition for number one, and then our confidence level. So in repeated sampling, we expect that this method will capture what? Well, we'll capture the true population mean car speed not car speed. How much? Well, 90% of the time. And I like to call number 10 our brag. I like to call it our brag because it's like, hey, if we did this over and over again, it's going to be successful 90% of the time. So we're claiming that we're going to be successful 90% of the time. If we've done a 95% confidence, be confident 95% of the time. This also means even though we're confident that it works 90% of the time, there's about 10% of the time we're not confident. Another thing I want to talk to you about the interval is that car speed, whatever they're driving on that road, the average speed of the population, not of the sample will be right in the middle every single time. The average speeds of the population, we believe to be somewhere between 55.8 and 63.415. In fact, I'm going to go ahead and draw a little picture of what we think is going on. So we took a sample. It happens to be normal. And our sample is always centered on X bar. All confidence levels intervals are centered on X bar. So this is 90% right here. We have an alpha, which is 1 minus 0.90, which means our alpha is 0.10, the area in the tails, and we have two tails, so this is 0.05, and this is 0.05, so that together they combine to form the 0.10. And then we have a lower bound and an upper bound. And we are 90% sure that it's in between those two values, the true population mean. And our X bar we calculated as 59.616. So this will be exactly in the middle, whatever this value is, when we have a lower bound of 55.8. So this is 55.8 right here. Then we have an upper bound of 63.415. Well, obviously our sample mean is there, and we also believe that our population mean is somewhere between the 55.8 and as high as 63.4. So discuss in statistical terms whether or not this would be convincing evidence to bring to the police department. Well, what they were worried about in the initial problem was that they were exceeding the posted speed limit, and the posted speed limit was 55. Well, 55 is not in that interval. It's close, but it's not. All right, so so the average car speed is above 55 miles an hour. So we can say because 55 mph is not mph miles per hour, not contained in the interval, and the interval is above 55, we have evidence, or better yet, we have evidence and are 90% confident the cars are speeding. Now we could probably on average. Now we can probably shorten that up and say because 55 is not contained in the interval and the interval is above 55, we're 90% confident that the cars are speeding, and this should be a 90%. So it says now calculate a 99% confidence interval and discuss whether we could take it. Well, we're going to write X bar plus or minus Z star, and we're going to have sigma divided by the square root of n. Well, we know X bar from above was 59.616. We're going to skip the Z star for just a moment, so leave a space for it. We said the standard deviation of the population was 8, and we had a sample of size 14. All right, so we're going to rerun this thing, but I need to get Z star first. So second vars, inverse norm, and I'm going to change this to 1 minus 0.99, close parenthesis, divide by 2. And I get 2.5758. 2.5758. And now I'm going to go ahead and do my confidence interval. So I'm going to go stat, test, number 7, which is Z interval. And everything is going to stay the same, except I'm going to change my confidence level to 0.99. And it goes from 53.668 to 65.565. So 53.668 to 65.565. Well, guess what? 55 lies within the interval. We cannot claim that the cars are speeding because 55 lies in the interval. We cannot claim that the cars are speeding. All right, so that concludes this notes. Thank you.